Right now, we live on a planet bursting with life, safely anchored by stable oceans and a predictable climate. But travel back exactly 4.6 billion years, and the Earth disappears entirely. In its place is an endless, freezing void. A massive, quiet cloud of dust and gas, mostly hydrogen and helium, drifts aimlessly through the darkness as the solar nebula. This peaceful drift ended when a neighboring star reached the end of its life and exploded into a violent supernova. The resulting shockwaves slammed into the nebula, triggering a massive gravitational instability that forced the gases to collapse inward on themselves. The violent death of that neighboring star provided the momentum for our own birth, knocking over the very first cosmic domino. The collapsing nebula flattened into a rotating disk. At its center, immense pressure ignited nuclear fusion. Our sun was born, absorbing 99.8%. The remaining 0.2% of scattered debris eventually formed every planet, moon, and asteroid today. Out in the edges of the disk, a process called accretion began. Static electricity and faint gravitational pulls caused microscopic dust particles to collide and stick together. Over millions of years, collisions compounded. Dust turned into pebbles, pebbles into boulders, and eventually into massive rocky planetesimals. Every mountain, ocean bed, and continent on Earth is constructed entirely from this scrap material left over from the sun's birth. During the Hadean Eon, Earth existed as a spherical, 8,500-degree ball of boiling lava, suspended in a constant state of bombardment by incoming debris. Inside this molten sphere, gravity pulled heavy elements down to the center, while lighter elements floated up to form a cooling crust. The dense iron core acts as a planetary generator, churning to project a magnetic field, shielding our atmosphere from solar winds. Just as the planet began to stabilize, a Mars-sized protoplanet named Theia violently slammed into Earth, instantly vaporizing a massive chunk of the planet's mantle. The debris from this impact was caught in Earth's gravity, clumping together in orbit to form our moon. Analysis of these lunar rock samples from the Apollo missions confirms this origin. Their chemical signatures are nearly identical to rocks found in Earth's mantle. That massive impact was off-center, knocking the Earth onto a permanent 23.5-degree tilt, creating the stable cycle of seasons we rely on for agriculture. Simultaneously, the gravity of the newly formed moon began to tug on Earth's oceans, creating tides that eventually helped early life transition from the sea to the shore. As the lava cooled, the new crust remained bone-dry and subjected to millions of years of heavy bombardment. The incoming asteroids and comets were actually carrying microscopic ice crystals. As they struck the hot surface, that ice vaporized, releasing massive plumes of steam. This newly released steam built a dense atmosphere. Once the air cooled, the vapor condensed into rain that fell for millions of years, filling the basins that would become our first oceans. Inside these early waters, microscopic bacteria emerged. These simple organisms survived by consuming minerals from underwater vents and absorbing energy from sunlight. As a byproduct of their survival, these microbes released oxygen. Over millions of years, this waste product transformed the toxic atmosphere and created the ozone layer that protects us from ultraviolet rays. The breathable atmosphere required for all advanced life today was initially generated entirely from the waste products of single-celled ocean bacteria. Hundreds of millions of years of evolution followed, leading to an era where massive dinosaurs ruled the newly formed continents. A final massive asteroid impact wiped out these giants. This extinction event provided the biological reset necessary for mammals, and eventually humans, to evolve. Our existence relies on a narrow set of margins: our precise distance from the sun, the strength of our iron core's magnetic field, and a delicate mixture of atmospheric gases. It took the Earth 4.6 billion years to balance its carbon cycle. Today, human activity is releasing carbon at a rate that tests the limits of that aeternitellence. After 4.6 billion years of cosmic accidents, the Earth remains a fragile, intricately balanced survivor. Its future now depends entirely on our stewardship.